So, I will start now with a very important chapter called storage for electric vehicles. Now, while I do that, I want to straight away attempt to answer a question that was posed to me at the end of the last lecture by a student. The question was, we had talked about efficiency for motors and controllers. Does battery also have efficiency? What does it mean? First thing is, when I charge battery, do I lose energy? Yes, we will lose energy. That will come as a charger inefficiency, not the battery, charger inefficiency. When we discuss charger, we will talk about the inefficiencies of that. But battery will have so we will have to always put in more energy than what goes into the battery. The charger inefficiency could be 5%, 10%, that much energy may be lost in the charger. Finally, certain amount of energy that will enter the battery. Battery inefficiency will be whether whatever is put in, can I take out all of it? Well, yes and no. Remember, battery also gets heated up, I mentioned that. There is a internal resistance associated with the battery. So, to that extent, energy that has gone in, part of the energy will be lost, except that loss is very small, typically 1%, and therefore, from efficiency point of view, you do not worry about it. From the heating point of view, you worry about it. Okay. So, that is the answer. We will get into more detail, because that is discussed in detail when we do storage for electric vehicles. I will now start talking about battery parameters. And as was pointed out, battery consists of cells. It is the cells which are put together to make a battery. Now, battery pack is much more than a cell, not simply assembling of cells, but yet the characteristics of cells are going to become also characteristics of battery to a large extent. So, when I talk about battery parameters, it may be also a cell parameter which gets carried into battery, and there will be additional parameters for battery. So, as I pointed out, what is electric vehicle? First of all, is a rechargeable electric batteries. There are electric batteries that we use. For example, in many devices, I have a car key which uses a small battery. It is not a rechargeable. So, I use it, after it is used, I throw it away. It is one time chargeable. Whatever it is, not even one time charge, I do not charge it, it is factory charge. It comes as a built in charge. There can be other batteries which are, you bring it without, buy it without charge, and you can do one time charge and then discharge. It is like one cycle. Now, those batteries are of very little use for electric vehicles or for a mobile phone, for example, or for a laptop. You want to keep on charging and discharging, charging and discharging. So, they are rechargeable battery. So, that is the first important thing. There are batteries which are not rechargeable or one time chargeable, we will discard, we will not talk about it in this course. After that, what is a battery? Battery is basically, I have been telling you, it is a storage of electrical energy for the, in this case, for electric vehicles. So, in that sense, battery is like a petrol tank. Petrol tank is a storage of petrol, or which is energy for ICE vehicle. Battery is a storage of electricity which is used to drive electric vehicles. So, battery is like a storage tank. A storage tank is made, petrol tank is made from aluminum and made fairly large, does not cost very much. You have to ensure that there is no leakage, of course, but does not cost that much. Not so with a battery. Battery is a complex unit, it is a storage of electricity, costs a lot, has a certain life. You will say even the petrol tank has a certain life. Well, its life is pretty much the life of a car, vehicle. Battery tank does not you rarely hear of a battery tank, something going wrong with the battery, not battery tank, with petrol tank. Now, if there is an accident, it may crack or something, but normally nothing happens. In fact, tank is designed to withstand a lot of pressure, because you do not want petrol leaking, petrol is dangerous. Electric battery, on the other hand, storage of electricity is very different. It costs a lot. The tank is usable only for a certain number of cycles, certain amount of time. After that, it is to be thrown out, replaced. So, in many ways it does the same function, but very different. This was introduced in chapter 1, but I want to point out that again, that electric vehicle by its very nature is 4 times more energy efficient than a petrol vehicle. And even then, when I compare a petrol tank, a filled petrol tank and a filled battery, battery fully charged, electricity fully charged, weight of a battery is 10 to 12 times higher than petrol tank, and its volume is 5 to 6 times higher than petrol tank. So, in fact, this curve, this shows very nicely. If you look at energy density kilowatt hour per liter, that is in volume terms, you see that diesel and petrol are close to 9.5 kilowatt hour per liter. What about for lithium ion batteries? It is about 1.5. So, 6 times, remember I talked to you about. And if I want to look at specific energy, kilowatt hour per kg, you see diesel and petrol comes to around 10-11 kilowatt hour per kg, and here 0.2, probably 0.1 or 0.2 kilowatt hour per, well, maybe little bit more than that, maybe a 1, something like 1 kilowatt hour per kg. No, it is not 1, it is about 250 watt hour per kg, but because of the 4 times energy efficiency, it effectively becomes 1. So, it is 10 to 12 times with equivalent energy. So, to worry about this is a key concern, difference between a petrol tank and a battery. We have discussed this in detail on what can actually happen, we will look at it. But another important aspect, while the tank is low cost, petrol is expensive per kilometer. Battery is expensive, electricity is inexpensive. So, you have a very big dilemma. Battery, petrol tank, therefore, very little capital expenditure, comes with the car, you have it or not have it, it will not make much a difference to the car cost. Battery is a high capital expenditure. Electric vehicle, once you have bought the battery, is only electricity costs. Operation expenditure, OPEX is small. OPEX for petrol vehicle is high, because petrol costs are high. Now, this is of course in India, petrol costs may be low in United States, so things may be different. So, why is the battery cost so high? Let us understand battery. To understand, let us start looking in detail at the battery. Consider a battery, 48 volt battery. You could have chosen another number, and let us assume a capacity of 15 kilowatt hour. This is an example, one could have taken any number, but just to show. Battery capacity is defined in terms of ampere hour. So, you take the capacity, 15 in this case, divided by the voltage, it gives you battery ampere hour. So, 15,000 watt hour, 15 kilowatt hour divided by 48, it gives you approximately 300 ampere hour. So, the battery is a 300 ampere hour. Remember, when you buy even a pencil cell, it gives you AH or milliampere hour. So, this is same ampere hour is the current, the voltage also has to be multiplied to get the capacity, or battery capacity is battery voltage multiplied by battery ampere hour. So, must remember that battery ampere hour is not the capacity. Very often you ask for a capacity and people talk about battery ampere hour, but it assumes that there is a certain voltage. You have to know the voltage to really understand the capacity. There is a very important parameter, and I have defined that in the past, I will redefine it. State of charge tells you how much is the battery charged, what is the percentage of battery that is charged. A 0% basically means it is totally discharged, 100% means it is fully charged. So, 100% battery of 15 kilowatt hour basically means it is a 15 kilowatt hour energy is there, and 0% basically means that 0 energy is there. So, this SOC is very important parameter, we will come to that again and again. Output voltage of a battery varies with SOC. Though we have said voltage is 48 volt, it is not 48 volt. For example, when SOC is 0, the battery voltage may go down to 43 volt. When SOC is close to 100, battery voltage may go to 56 volt. As the battery is charged, its voltage keeps on going up. When it is discharged, voltage keeps on coming down. 43 is SOC of 0, 56 is near 100%. This you must remember, and we will come to that later on, which basically means that motor people will say, I want so much voltage. Well, voltage will vary. It is not going to be a constant voltage. Motor has to worry about these things when it designs. Motor controller has to worry about it. So, there is a parameter that I have been talking about, charging and discharging rates, or charging and discharging at what is called C rate of a battery. C rate is somewhat called charging rate, but it is also used for discharging rate, C rate of a battery. A 15 kilowatt hour battery, you often talk about 1 C charge or 1 C discharge. It is a 15 kilowatt hour. What does it mean? It can actually have 15 kilowatt for 1 hour. It can charge in 1 hour 15 kilowatt, or it can discharge for 1 hour 15 kilowatts. So, 1 C charge rate and discharge rate for 15 kilowatt hour battery is 15 kilowatt. 1 C basically means in 1 hour you can charge or discharge battery, that is called 1 C. The C rate is in some sense hours, 1 C basically means 1 hour. Can discharge or charge battery from 0% to 100% in 1 hour. Now, you may not use it from 0% to 100%. So, to that extent it will take less time, that is a different matter. But if you did go to 0%, you can go, there is nothing prevents you, you can go to 100% and If you do it at 15 kilowatt, it will take 1 hour, and that is the reason it is called 15 kilowatt hour battery, or 1 C charge and discharge is 15 kilowatt. What about 2 C rate? 2 C rate means rate of charging and discharging will double of 1 C. 2 C does not mean 2 hours. 2 C basically means half hour. This is very important. It is a double rate. It is a rate. C rate is a rate of charging and discharging. 2 C means 1 C is 1 hour. 2 C means it is charging at half hour. It is double the rate. 2 C basically means it will charge and discharge at 30 kilowatt. So, therefore, it will take only 30 minutes, half an hour. Do not make a mistake that 2 C basically means 2 hours. It is 1 by C hours, 1 by C rate hours. Okay? 2 C rate. Similarly, 4 C will means you will charge discharge in 15 minutes. It means 60 kilowatt charging and discharging. On the other hand, if you make it not 1 C but 0.1 C, 0.1 C means it will take 10 hours. 0.1 C is 1.5 kilowatt charging and discharging. Okay? 0.2 C will mean 3 kilowatt charging and discharging, and it will take 5 hours. So, is that understood? And so, for a 15 kilowatt hour battery, if a vehicle requires a power of 30 kilowatt, you have to discharge at 2 C. It is the vehicle which decides how much power is to be done, it is not the battery. Whenever battery requires 30 vehicle requires 30 kilowatt, you are discharging at 2 C. If vehicle requires only 5 kilowatt, you are discharging at 1/3 C, C by 3. Okay? So, the vehicle or the motor requirement will decide at what rate you will discharge a battery. Now, generally I want to point out that there is something called slow and fast charge. This is a term that is used for charging. If it is much less than a C, it is slow, 0.2 C, 0.3 C, even 0.5 C you can just say it is slow, and fast is greater or equal to 1 C. So, a fast charger basically can be 1 C, that means in 1 hour you can charge from 0 to 100%, or can be 2 C, which means half an hour you can charge, or can be 4 C, you can charge in 15 minutes. So, I have done the definition so far: depth of discharge, state of charge. I have not done depth of discharge, state of charge of the battery, battery capacity, state of charge, and then C rate of a battery. So far that is what I have done. So, I have given assignment just so that you can get familiar. A 34 kilowatt hour battery is charged at state of charge of 64%. What is at SOC of 64%, what is the energy it contains? Or a 34 kilowatt hour battery is at 350 volt, what is the capacity in AH? A 3.5 volt battery is at 2.7 volt at a SOC of 0% and 4.3 volt at a SOC of 100%. So, this is a 3.5 volt battery or a cell. It varies from 0 to 100%. This implies the voltage of battery lies between 3.5 plus minus delta volt. 3.5 is the nominal voltage, is a plus minus delta. What is a delta? Assuming SOC is a linear function of the voltage, that is assumption, that in reality that is not true. What is the SOC at 4 volt and what is the SOC, what is the SOC when it is 64%, when SOC of 64%, what is the voltage. Then I also given you compare petrol volumetric energy density in kilowatt hour per liter and gravitational kilowatt hour per kg. Well, I have given you the in that diagram, but take it out. Coal volumetric energy density in kilowatt hour per liter and gravitational in kilowatt hour per kg. I don't know the coal is there or not there. I think I had given you an assignment earlier. Coal is there. Coal is there. So, this picture gives you a very good idea.